This is section 3.4. This is arc length and area of a sector. So what you need to do right now is find your salmon sheet, because the two formulas that we're going to use today, arc length, you need to find that on your salmon sheet. This is what you'll be able to use on the test. And the other one's going to be area of a sector, which is just below the arc length formula under the heading of circular motion formulas on your salmon sheet. So we're going to be able to refer to this. One thing you must keep in mind, theta in this formula always must be in radians. Okay, so that's the only way the formula works. If they give you any degree measure, you actually have to convert it to radians. So this is the importance of radians instead of the degrees that we're most comfortable working with. So if I say find the length of the arc cut off by a central angle of 3 radians. So if I draw myself a circle, I know that that's the start of my circle. Here's the center. 3 radians, we should know by now, is just a sliver underneath pi, which is half of your circle. So I know that my theta, my central angle, is 3 radians. So that's this angle right here. And then my radius is 5.4 centimeters. Okay? And what I want to do is find the arc length. Arc length is simply just this part. Okay, so if I'm asking for arc, I need to find this formula. Arc length is the radius times your angle in radians. So since this is really simple, because I have 5.4 centimeters times my 3 radians, and radians is not a label that actually has a concrete number or a label attached to it, so it kind of goes away if it gets multiplied by anything else. So my arc length will end up being 3 times 5.4 gives me 16.2, and the label that comes out is the centimeters, because it ends up being a distance. Okay, radians is not a label, it's just actually a nice neutral label that we can use. So it ends up being 16.2 centimeters because I was given the radius and theta in radians. So another example would be the minute hand on the clock is 1.5 centimeters long. How far does the tip of the hand move in 20 minutes? Okay, so we got to think about a clock from beginning of the hour to 20 minutes. So if I travel all the way down, I need to figure out how far that distance is. Well, that's referring to the arc length. So once again, I'm going to think about my arc length formula. I need to know a radius. Do I have a radius? Everybody should be like, sweet, yep, because I have 1.5 centimeters long is the minute hand. But I need an angle in radians. So here's the tricky part. A lot of us like using circles in degrees. So if you think about 20 minutes, what fractional part of an hour is 20 minutes? Well, 20 minutes ends up being a third of an hour. Okay, and how many degrees is in a third of a circle? So 360 divided by 3 gives me 120 degrees. The problem is if you put 120 in for theta, you will get the wrong answer. So what we need to do is convert 120 degrees into radians. So I need to times by pi over 180. So if you think about a third of a circle, or if you look at your blue sheet and look at the unit circle, or just simply say, hey, 60 goes into both of these, twice here, 3 times here. 120 degrees is 2 pi over 3. So I can dump that in, and I end up getting my arc length is 1.5 centimeters times 2 pi over 3. And you end up getting 2 times 1.5 actually is 3. 3 over 3 is 1. So my arc length is actually pi centimeters, or you could multiply all of it out and get 3.14 if you actually want to get yourself a decimal. Okay, so that's actually the arc length. That's that distance right here with that length, radius, and that angle. Okay, here's the other formula. Area of a sector. Okay, 1/2 times the radius squared times your angle. Okay, so what we need to do now is, if you're asking to find it, same principle applies. Can you find the radius? And your angle must be in radians. So find the area of a sector formed by a central angle of 2.5 radians. So let's say this is your 2.5 radians. And then the radius is 10 centimeters long. So if you actually can be able to do that, I have all the information I need, because my angle was in radians, which I need, and I have the radius. So the area is 1/2 and this is 10 centimeters squared, and then times your theta, which is 2.5 radians. The radians is a neutral label. So how do I end up doing this? 1/2 times 100 is 50, times 2.5 ends up being 125. What is my label? Thinking area, you should think square units, so centimeters, and I have to square it. So that's where my label comes from. I'm emphasizing these labels because it's going to come up in 2.5 and it's very important. So area would be 125 centimeters squared on this particular problem. So let's throw you for a little bit of loop. Let's say I give you a sector formed by a central angle of 15 degrees. Okay, so you should instantly think that's not good. Okay, I cannot use 15 degrees. What I need to do now is figure out how I can get that into radians, because my area, which I didn't, I have an area of pi over 3, so I'm going to use my area formula. So I'm just going to write that down. Now, what do they give you? They give you the central angle of 15 degrees. First of all, you can't put 15 in there. So let's deal with that right now. So 15 degrees in radians, I need to times by what? Pi over 180. So think about how many times does 15 go into 180. It's 12 times. So I end up getting pi over 12. Alright? That is my angle that I need to shove in for my theta. What else is given? Has an area. So they actually give you the full out area this time, and they want you to find the radius. So we're going to end up solving for r, so this is going to be kind of entertaining. So we have pi over 3 equals 1/2 radius squared. I don't know what the radius is, but I do know that my theta is not 15, it is pi over 12. And what we need to do now is solve for your radius. So I need to, in however or whatever order you want, we need to get rid of this. So how would I go about doing this? I'd multiply by 12 over pi to both sides. 12 over pi. So pi's cross out. And I end up getting what? 12 over 3 is 4. And then I'm going to multiply by 2 to both sides. So I get 8 equals r squared. And then how do I get r by itself? You have to take the square root. So r is going to equal plus or minus the square root of 8. Now if it's a radius, the negative obviously is not the answer. So it's going to end up being 2 root 2, and the positive direction is your radius. And actually I should label it, so that actually wouldn't be the best way to say it either. So r equals 2 root 2, what's my label? Centimeters, because they said the area was centimeters squared, so that means my radius is just going to end up being centimeters to the first power. Alright, so that's an example of when I give you area and I give you a degree measure and you have to find the radius. So there's a variety of things that you might end up having to do. And then the last problem I'm going to show you is more of a word problem. Lawn sprinkler located at the corner of a yard is going to rotate 90 degrees. So I know this is a 90-degree angle. And project water out 30 feet. So that's 30 feet in any direction that you want. And I want to, now to 3 significant digits, once again, I don't like this significant digit thing, so let's just assume round to 100th spot unless I say different. And what is the area of the water sprinklers that it's going to hit? So once again, if I say area, just write the area formula down. 1/2 r squared theta. Can I find my radius? Well, radius is pretty easy, because I actually tell you that it rotates 30 feet squared. And then what is my angle? If this is 90 degrees, what is 90 degrees as a radian measure? Now, hopefully some of us instantly recalls that it's pi over 2. If you don't, that's okay. 90 goes into 180 2 times. So that's your angle that you dump in here. So times pi over 2. And so we end up with the area of, if I wanted to dump all this together, I have to square it first. This would be 900 pi on top. The 2 times the 2 on the bottom is 4. So obviously I can, and this will be feet squared, I can reduce all that to 225 pi feet squared Or if you do multiply by pi, this would be like more of the exact answer. Okay, and then if I just say, hey, approximate to the hundredths place, area would equal 706.86 feet squared. Okay, so this would be your approximation right here, and your exact answer would actually leave it as in terms of pi. That's exact as you can get. So here's an example of an applied problem. We will work on these problems tomorrow, and I hope you all have a wonderful day.